click on records. People ask to record this. So we are recording just the presentation portion of this. So hopefully by the end of the night, you'll have a good idea as to what a microservice is and what it's going to kind of mean for you from a data perspective. So feel free to jump in with any questions. I may or may not have the answer, but it'll be interesting to hear people's perspectives. So. All right, so kind of, I'm not really going to post an agenda here, but these are the kind of questions that hopefully I'm going to answer by the end of the night. So what are microservices? What are some of the pros and cons? What is an event? So that becomes a big thing as well. And then how does this impact you from a data perspective? So, hopefully we'll answer those questions tonight, but feel free, if you have any other questions or you have a question, feel free to pop in at any time. All right, so what is a microservice? And I took this from this article by Martin Fowler, and if any of you don't know Martin Fowler, if you haven't been in software, maybe that you may not, but he's a really great software architect, and just he works for ThoughtWorks. So he's really smart guy, does a lot of software architecture stuff. So this was kind of his definition, and I kind of made some emphasis here. So the emphasis on the things is mine, right? So when we talk about microservice, it's a way of designing applications, and it's a kind of basically a suite of services, and to kind of differentiate it from what's typically called a monolith, right? So typically when you see an article talking about it, it'll be like you have microservice on one side and monolith on the other side. And to kind of put that into perspective, like a monolith it's an application that's all in basically one big bundle. Like when you deploy that application, you deploy the whole thing as one shot, right? So let's say the equivalent might be, let's say you were installing a piece of software. I'm just kind of use an example, maybe like TurboTax, right? So when you install TurboTax, it's one setup, right? You click it and it installs the whole thing, right? But a monolith or a microservice, so you could kind of consider that a monolith. What a microservice be like, you might have each of those things and you'd install all of them independently. And they wouldn't be as part of one big setup. And you could get updates to each of them independently and those kind of things. So it may not be a perfect example, but that's kind of the difference between both a microservice and a monolith. And even this is Martin Fowler, he's saying, like, well, there's no precise definition, right? And I agree with that. But there are what I would say like common characteristics or drivers for microservice architectures, and those are business capability, automated deployment, endpoint intelligence, and we'll talk about what that means, and kind of decentralized control. So I put a link to this article. If you just search for Martin Fowler microservice, you'll find this article. It's a really good article, and it's short too. There's multiple books out there on microservices as well, but it's a really good article. I'd suggest if you're interested, give it a read. All right, so when we talk about business capabilities, what we're talking about is that when you build teams, so typically in a microservice, let's say a company that's practicing microservices, typically you're building your teams around business capabilities versus technical capabilities. And so what that means is that you have a team, for example, that is focused on, let's say, search. So I'm going to take one of my previous companies' example, which is Pluralsight. Most of the people have probably used Pluralsight before or some other kind of training platform. So it probably fits pretty well, right? So there's a search capability in Pluralsight on the site. Well, that functionality, that business capability is owned by one team. So one team owns that capability. They own the UI, they own the software, they also own the database, they also own the administration and the operation and support of it. So within that product team, they own the that entire product from beginning to end, from the UI all the way down to the database. So that's the main difference there. And this is in contrast to other types of organizations where you have, let's say you have a front end team and they're all on one team, they're under one manager, and they work on different projects, right? Depending on what you're doing. And you might have a middle tier team, and then you have your database team that does all your stored proc development, for example, and all your database stuff. So that's kind of the difference, right? Where you have teams built around business capabilities versus technical capabilities. So typically those teams are also cross-functional, right? And they're focused on those specific business capabilities. So on that search team, for example, I'm going to have somebody who does UI. They might be, using. I'm not a UI guy, so whatever UI, Vue.js or whatever JavaScript framework you want that's going to do the UI, you're going to have some software developers that are building services, and then you might have some database people that are using doing database development. But it may not be. A lot of the teams at the Pluralsight were, a lot of the database access was all through ORMs, and so they didn't really have database people on the majority of the teams. But they're cross-functional. They own everything. They may also have a DevOps person on that team that's focused on kind of deploying their services and supporting services, things like that. So those teams are cross-functional and they're focused on that specific business capability. And it might be multiple capabilities depending on how large or small the capability is. So there might be, they might own a really small, might own like 5 capabilities, for example, but some of them are really small. They don't have a lot of active development or something like that. And so those teams are focused on products versus projects, right? So one of the challenges when I kind of highlight that as products versus projects, right? So what happens typically, like in this case, this product team, that product team owns those products from start to end. Like they never give up those products. I mean, you can reorganize products and kind of reorganize teams, but for the most part, like the search team owns search forever, right? That product team owns search versus projects, right? So projects are like, okay, hey, we need to add this functionality to the search page. We're going to spin up a team, grab people, we're going to develop it, and then we're going to deploy it, and then that project team goes away, right? And one of the challenges with that is because once that project is done, those people all disperse and go elsewhere, right? And there's nobody necessarily dedicated to support of that, any kind of ongoing development. So if there's a bug, for example, now maybe you might have this, sometimes organizations have a team that's solely dedicated to handling support, right? And that's all they do is like bug fixes and things like that. One of the challenges with that is there's not a lot of people that really always want to be solely on just the bug fixing team, right? Because you don't work on big features, things like that. So that can be a challenge. And they also don't have the business knowledge, right? So this product team has that continuity of knowledge about search. Like what did search look like 2 years ago? What did it look like 1 year ago? What kind of new features do you want to build into search? So there's a lot of ownership, right? So a lot of it is talking about ownership. So this team owns that development. They own the development, the operation, the maintenance, new features, things like that. So that product team is really focused on that business capability, and that business capability lives on, and that team always owns that. So there's a lot of, you'll hear ownership a lot, because ownership is a lot of what kind of microservice architectures enable. Let's see. So the next kind of piece is these what kind of termed smart endpoints and dumb pipes. So basically meaning that, hey, all your complex logic, Philip, I'll get to your question here in just a minute. Products are owners of the complex logic. So if you have business logic about, how searches should happen, how they should be returned, what the algorithms are, those kind of things, those are owned by the product team. And any kind of communication between services, and we'll get to communication in a little bit when we talk about events, but any kind of communication between those pipes is very simple, right, versus complex. And this is kind of more different than, when you have a pipeline between, say, two services, and you put a lot of logic into, say, the ETL, or the logic that pushes that data back and forth, right? It's intended that the communication is very simple, because with all of these microservices, they need to communicate a lot. So you need to make that communication simple. And the last thing is, like, again, ownership of the logic. It lies in the products that are producing the data, producing the messages, and consuming the communication. So in most cases, I'm going to use communication. I might slip back and say events. It doesn't have to be events, but we'll talk about that in a little bit. Okay, so Philip's question here: seems like microservices is analogous to functional partitioning, separating parts of an application to different servers. Sort of, yes. A lot of it is, if you're separating out kind of the deployment, those things have to communicate via some other form, right? Then that can be either APIs or events. But yes, you're kind of separating them physically, right? In terms of, they have their own databases, things like that. So one of the things that you can't do, right, is, say, if I have 20 services and I can deploy them, but they all talk to the same database, for example, that's not a microservice architecture, right? So a microservice architecture, that ownership starts from the UI all the way down to the database, and the full stack is owned, and it's not, you're completely separating that from other services. And let's see, so Parag, true with other constraints like strict boundaries, stateless processing, and data segregation. Yes, so again, it's very strict. You want to keep those boundaries of what the services are fairly strict, and so that you're not crossing services. So once you start getting the cross between services, then you start getting back into what's more of a monolith, and you have a lot of these. If you've ever been in an organization where it's like, okay, hey, I need to deploy this application. Oh, wait, hold on. Before you do that, because you're deploying that application, you need to deploy these other things, right? Because they need to be in the same, on the same either same version or whatever. And so now your small little change is a 2-month deployment process, because you got to deploy all these other dependent services, right? That's really what we're trying to get around. Okay, so the other kind of main goal is kind of decentralized governance, right? So, the teams are free to utilize their tools of choice, right? And that seems kind of scary when you say it just like that. However, they do have to own the full life cycle of their technology choice, right? So it's not like they're going to go out and say, hey, I want to use technology X. I'm just going to use Mongo, for example. Nothing against Mongo, not saying it's a bad technology or anything like that. But if nobody else is using Mongo in the application or in the company, there's a much bigger jump, right? Because not only do you have to know how to develop with it, you have to be able to support it. Is it being backed up? What happens if it fails? What happens if it goes down? There's all these kind of scenarios from an operations perspective, excuse me, that the team has to own, right? So if that goes down, it's not like they can call up somebody else and say, hey, well, so I just developed the thing, right? You're the support team, you got to support it, right? Now the team has to own it, right? The team owns it, and if it goes down, the team owns it, right? So that's a big driver in a lot of the decisions, right? The, there are some things that you do have to have some coordination for, regardless. One is how the services communicate with each other. So all the services need to have a common way to communicate, because if you don't, then then you're going to be in this place where it's like, okay, I need to support 5 different ways for how services are going to communicate. And then that's going to be really hard on anybody who wants to develop a new service, because now you have to try and do all these different ways to consume data, right? So typically you have a very common way to communicate across your services. And that kind of emphasis is also on developing what I call shared approaches and shared libraries, right? So um, one of the things that tends to happen is um, that you typically have common things that the company does. And I'll use Pluralsight as an example. For the most part, any microservice that wanted to use a relational engine, they'd all use the same one, right? And that was Postgres, right? So they would all use Postgres because, hey, they had a common way for accessing Postgres. They had some libraries that had been developed that the teams can share on how to communicate with Postgres. They know how to support it. They know how to back it up. They know how to do, all the operations around it. They know how to deploy it. All those kind of things are shared approaches and shared libraries. So for the most part, if you're a new microservice and you want to develop a new feature, if you say, well, okay, everybody's using Postgres, yeah, but I want to use MySQL. Well, all that stuff that has been gathered and developed for Postgres, you have to redo all of that. And so it's a much bigger leap to kind of get new technologies in. And so there's definitely some work that somebody would have to do to get new technologies in. So they tend to, you tend to find what I tend to find is like, hey, here's a particular type of problem and you need this type of database. And so there's some knowledge about that. So in the case of search, like, okay, we need like a full text database. Well, everybody, somebody else is using Elastic, so we can just use Elastic too. Things like that. So it tends to be that there's common sets of tools that everybody kind of knows and uses, and so those become really easy. So if you're starting new development, like, oh yeah, I'm going to use Postgres and I'm going to use Elastic, right? So at that point, everybody knows what they are. They're a known quantity, so it's much easier to kind of get moving. And so, okay, so the question is, so like on Amazon, maybe one microservice is product images, another is product search, another is a set of microservices around the service cart. Yep, like stored addresses. Yep. Daniel, I think, yeah, you're absolutely correct. You'll see each of those services are independent of each other. And I'm sure there's probably even more than one team, for example, that does either of those areas, just because Amazon is so big. But yeah, I think you have it right on the hit the nail on the head there. Okay, so that also leads to kind of decentralized data management. And I've talked to some of these things, but again, teams are free to choose or change the data storage platform that best suits their product. And this is kind of typically called polyglot persistence. And you'll hear that term with microservices because you also get polyglot languages, because there might be multiple teams using different languages for different reasons. Those kind of things as well. So there were teams that used, majority of them used Postgres. I don't know if any of them used Mongo, but I know they had Elastic. A couple of them actually used Cassandra for some different things. There might be other ones now as well, but they all had the freedom to choose a technology that fit what they needed to do, the right technology. So what they do need to do is they do need to share metadata about their data contract and how they're going to communicate, right? Because the communication profile is all across, is based off these contracts of what data they're sharing. That is what they do need to share, right? So you don't need to know what database they're using. Doesn't matter if you're getting data from that microservice, but you do need to know what data they're making available. So, so they need to communicate that contract, and they can change and update that data contract, which is definitely one of the challenges. So Matt, to your question, one team on Azure. So yeah, I agree with Dustin. You know, Pluralsight, it was all AWS. You know, if you're building a product, I gather it would be pretty hard to do that. You know, if you have part of the app on Azure and part of it on AWS, I just imagine that would be the case. But I could see it happening where you might do, let's say your data team is in Azure, but your apps are in AWS maybe. But the challenge is getting that, is getting the communication and the security right across those two, that boundary. You're also going to be paying for that data export and data import as well. So any kind of data transfer between the two, you're going to pay for that, especially on the outbound. So definitely have to keep that in mind as well.
Money is no object.
Yeah. So that's another interest. I mean, if you talk about cloud, you know, getting a bill every month tends to get people really concerned about cost. Okay, so maybe I should have had this earlier, but I wanted to kind of get through all of those and can kind of show an example here. So this is kind of your monolith on the left-hand side. Yeah, good question, Dustin. The monolith was on the left-hand side where you got the UI, data access layer, business logic, and on the right-hand side is you have the microservice architecture. So you have your UI, and you know, each of the microservices. If you notice, like, you know, the 4 microservices on the bottom, they're actually storing data. There's a couple microservices here that are a little bit higher up that are actually, all they're doing is communicating with other microservices. And that's very possible as well. Sometimes you have coordinator services, depending on how complex your apps are. But basically, they're all separate. They're all separate teams, all separate products, and they're all deployed independently. So. Okay, so let's talk about events, and you know, so usually this comes down to a decision around events versus APIs, and what you'll want to know is kind of how the organization, and this is very almost a philosophical discussion for whether you want to do events or APIs, and the main reason is, typically the high level is events are a disconnected process, right? So if I'm a microservice and I'm producing an event, I send that event out to some communication platform, and other microservices, if they're interested in that data, will subscribe to that data. And they'll consume that data into their service. So that's a very disconnected process. And because if, let's say, you know, if my microservice is dependent on data from another microservice, what I'm going to do is I'm going to subscribe to that event, and then I'm going to store that data within my microservice. Because what I want to be is I want to be completely decoupled from that other microservice. And so if that other service goes down, I can still operate. And so that's one of the things that's a failure in kind of like an API scenario, where if my service is reliant on some other service being up and available and answering an API call, like a REST call, if that service is down, my service is down as well, or I need to handle that situation where that service is down. So I would say that the majority of microservice architectures are based on events. There are pockets where you do have APIs, but for the most part, when you say microservice, you're typically looking at a architecture that's communicating via events. So when we talk about events, I want to be, this is one of the interesting discussions that we had at Pluralsight when we really came in as a data team, is understanding kind of what and I put them in what type of events there are. And I put them into kind of 2 buckets. And the reason that I put them into two buckets. There might be more, but these are the ones that I kind of there was what I called the domain event, and the other one was I called a database event. And the difference between the two is that a domain event is an event that tells me that something happened, right? So let's say I purchased something on Amazon. So the cart service, for example, may send out an event that I clicked the order button, right? So it says, created order would be the service, would be the event type. And that created order event is going to have a lot of attributes on it. There's going to be multiple services that are going to listen to that event. One is going to be probably the credit card authorization. One is going to be inventory. One is going to be who knows what else. But that's what I call a domain event. A database event would be more like an event captured through like change data capture, or some other type of service where it's basically listening to whatever database the service has and producing events based off of those. And it's slightly different because your domain events tend to sometimes be a little bit more complex and have a little bit more content to them, where your database events may be a little bit more simpler. And the database events are a little bit quicker to get going if you use something like CDC or something like that. But your domain events, are typically going to have, I'd say, a bit more modeling around what the kind of event means. So those are kind of the two main events. And so if you're, let's say you're a data person and you're talking to a microservice, and they're saying, okay, we're giving you events, you might want to ask like, hey, is this a domain event? How are you generating the event? Because you want to have knowledge of how they're doing that. Okay, so probably talked a little bit about what some of the impacts are, but we'll finish with this and then we'll take questions here. So what does the data, and I use data at a high level here, like what does the data team kind of need to know about? What do they need to do, right? So these are some of the things that the data team needs to be. Let me just say this. Alex said, what would be an example of a database event? Sure. So the example of a database event might be, let's say that my database is Postgres, and I'm an order service, and my order is comprised of an order header, order detail, and addresses, which contain my billing address and shipping address, right? If I'm looking at that as an event, right, like an order event, I might have one message, right, that's going to have, here's my order header, here's my detail line items in a sub element in my JSON message, and then I also have my addresses in a sub element of my JSON. So that would be what I would call a domain event. The business events associated with that would be, in my relational database, I might have three tables. One would be my order detail, one would be my order details, and the other one would be my addresses. And so if I'm doing a database event, I would have one event for my order detail. I might have an event for each of my order line items, and then an event for each of my addresses. So it's more like a replication stream than a kind of domain event, if that makes sense. Feel free to ask, pop in later if that doesn't clarify it. So back to what the kind of data team needs to do. The first one is, hey, you need to be able to kind of source data from multiple services and consume events, right? So this is different than if you were a traditional BI developer before, where you're generally getting big files, you're getting dumps of data, and you're just consuming those files. Well, now you're going to be getting all these events in a kind of real-time fashion, and you need to be able to consume those and from multiple services. And you also need to be able to dynamically add those, because at Pluralsight, it was like every 3 or 6 months, there'd be new services or new product teams spin up, or they'd take a existing product team and split it into 2 product teams. And so there's new features being added all the time. So you have to have this degree of flexibility to be able to consume data from all of these services and easily add new ones. Also need to really be able to handle changing schemas. So, one of the kind of the goals is that the microservices, because they're kind of independent, is then they can be deployed, they can upgrade, they can do anything that they want to do, as long as they're kind of adhering to that communication contract. So they can push out new versions of the contract, and however you're consuming that needs to take that into account, that hey, at any time you could have this service upgrade and say add some new fields or something like that. And it's once you get to a certain size, it's going to be basically impossible for a data team to keep up with all of those changes and have any kind of process associated with those, because you'll quickly become overwhelmed, because those product teams tend to multiply, and the data team doesn't always multiply in the same fashion. So you definitely there's definitely a challenge of always having to keep up. So the more dynamic you're making your architecture and your framework for how you're consuming, the better. So handle the changing schemas and basically being able to make it available for analysis. Now, when I say make it available for analysis, I'm not saying that it needs to be in a data warehouse or a cube or any kind of structured analytical data set, but it needs to be available for somebody to run a query if they want to on the raw data, because I can guarantee you as soon as that data is available, somebody's going to want to query it. It might be a product manager, it might be somebody who's interested in, hey, how is this new feature working? Those kind of things. So you're going to want to have that available, and then monitoring workflow to tie it all together. One of the other challenges is it's not a job that run once a day and you can kind of watch it and rerun it. This thing is generally running all the time, consuming events all the time, and making things available. So you have to have monitoring and kind of a workflow engine to kind of put it all together. All right, so I don't know if I did 15 minutes or not. I think I went over, but I tried to get it as kind of quick and concise as possible. Okay, so Andrew, when you think of data contracts, what good practical examples come to your mind? Sure. So good example, one example is something from Confluent called schema registry. Schema registry is capability within, well, it's kind of separate from Kafka, but it's basically a data catalog, and you can register your contracts in there, and you can utilize those contracts. You can validate events based off those contracts. You can also read at a particular contract level. So there's some cool things that you can do there. At my current position, we're looking at using JSON schema, which is another basically kind of way to describe a schema. So there's probably other ones that you can potentially, some people will use data catalogs, so like the Hive Metastore as kind of the repository, and kind of utilize that as kind of a contract for what you might get. So data, like a data catalog application might be useful in those kind of things, but schema registry, if you're typically talking microservices and you're talking Kafka, is probably a natural to take a look at. If you're not using Kafka, probably something like JSON schema. There might be others out there.
And maybe to add, like, it could even be just the schema is documented in a wiki, and that's what's agreed upon. And if they're going to change it, it either needs to be a small change that everyone's okay with, and you usually define rules around that, or it's a new version and they're going to send the data with the old version and the new version for a while until everyone's migrated off.
Yeah, and that's a good point, Dustin. The other thing I was going to add on to that was things like Glue has its own data catalog as well. So if you're using something like that, I believe the Azure Data Factory, the can't remember the name now, the user flow, I believe, has the same kind of capability of managing schemas and looking at, and identifying when there are schema changes, things like that. So there's definitely some tools there potentially, but it's definitely a challenge there. How do you handle failures in a data stream? Well, I don't know if we have enough time for that one. A lot of it has to be segmented on a putting things to the side. So, if I get in this event and it's causing an issue of some kind, depending on how you do it, you could either put it in a dead letter state if it's directly on, say, the queue, something like that, or you're going to put it into some data store that's like quarantine or error store or something like that, because you don't want to hold up your processing. You want it to kind of keep going, and you'll kind of deal with those errors as you need to. It also depends on what your level of tolerance is for failures in your data pipeline. So some data you're okay with not getting it all. So I think I was at I can't remember how many years ago, but it was a talk where the one of the data quality people from Netflix was up talking, and they were talking about their data load and the amount of data that they lose. And I think it was like 1.5% that they were okay, right? Because this was like your video events as you pause or do whatever. And so if they're not quite 100% okay, that's okay. And so the funny thing is if you did the math, in general, the amount of data that they lost was like twice the amount of data that we even had in our entire environment, which is kind of scary. But so that's one of those things you need to figure out what your tolerance is for failures there. So you're basically putting a proxy behind all your microservices to combine and streamline everything until they decide. Yes, I mean, in general, what I've seen is that you're going to want to get all of the data, and you're probably going to want to stream it to a data lake, right? Is something like a data lake, because your data lake is going to be super flexible, right, in terms of handling all these schema changes, new events, things like that you're like, hey, I'm getting it and I'm going to drop it there. And then you probably will have some of your logic in kind of the query side of things, right? Let's see. And how do we get data in bulk? So direct APIs may not be good for exchanging bulk data. What about the case? Yeah, so, okay. So bulk data is definitely a challenge. And I would say it's a challenge that we didn't necessarily solve at Pluralsight. One of the challenges is in an event stream, it's hard to kind of go back, because depending on your services, they may look at it as, hey, I published an event and I'm done, right? So you want that data, you go to that event. Now, what the challenge with that is that, what if I just start listening now? How do I get because I might want the data from like a year ago, and I want to get all that data. So some of that, you really have to kind of talk about that. I would say that's probably one of those kind of fundamental kind of communication platforms that you need to talk about. So, let's say you're using Kafka. Kafka can be used as a data store. It's, I think they're trying to push it more as a data store these days. But let's say you're only storing 3 months of events in your Kafka store. You're probably going to want to have some process to ensure that everything on those Kafka events gets stored in data lake right before it gets removed. So you have that kind of bulk data. If you're going to do it a lot, at Pluralsight, they really only needed to do bulk stuff out of the services when a new service was being stood up, right? So it wasn't, I would say, frequent enough to where they had a common way to do it. Some of the services had better ways to do it, but than others, but it certainly wasn't something that was kind of across the board. And go ahead.
If I can add, Andrew, one thing that I just saw recently is Confluent's latest platform. I'm not sure if it's made into open source Apache Kafka, but on Confluent's latest platform, they have a persistence capability built in where you could set up topics to, I don't know if it's archive or also write to, S3 or Azure Storage, or I assume Google Cloud Storage automatically, and just have I believe then the API can go read that or read from Kafka, depending on how much data you're trying to get, which sounded like something that I know a lot of companies have implemented a similar style of thing for tracking all that history and being able to go back in time beyond what Kafka is storing.
Yeah. And they have, I'm trying to think of, I'm blanking on the, but I know Kafka, for example, has some very simple data streaming pipelines where if you like, hey, I just want to make sure I capture all of this data, want to replicate this topic and just replicate it to, say, a data
Kafka
lake.
Connect's probably what you're thinking of. That's
Yeah,
kind of
exactly. Yeah.
straightforward. Just write this to a data store.
Yeah. So that's the other way. Like you want to make sure you get it if you really can't lose it and you want it all, and you want to make sure you have all that data. You do need to plan for that. And so your question, what about the case where the exchange is across organization boundaries? In terms, I guess, Parag, is that outside your own organization or within your kind of same different departments within the same company?
No, I meant B2B, right?
B2B. So yeah, I mean, it really is all about security at that point, right? So if you, let's say you have a Kafka topic on your end, there is some, I believe, some technologies to kind of duplicate that. So if you can set that up, you could duplicate it across from your Kafka topic to their Kafka topic. You may also, want to, it's almost like an EDI type of thing that you're kind of talking about now, where I'm publishing an event to some endpoint, right? So it's really about, making sure you have that secure setup. But it can absolutely be done. Cool. Any other questions?
I can give you a kind of real world example I saw recently. Basically a service provider providing data, or actually had built the application that collects, tracks orders and the operations. And as the BI group, we were pulling in the data and they were changing the schema, which particularly happens when the product is new or undergoing some kind of V2, next revision, where you're going to have significant changes in the tables. And this happened to be happening constantly. So every time they did a deployment, which was a week or so, there'd be schema changes and we'd have to change everything. It was an incremental loading process. So we did initially, as Dustin suggested, we just got in on the deployment schedule and we were required to sign off before they deployed, which usually they'd give us a day's notice. We'd review the changes, make sure that it wasn't going to mess anything up, and then we'd give them the go ahead and sign off, and then they do the deployment. And then later we, because we realized this problem wasn't going to go away, we actually implemented a hot standby, a Postgres hot standby that was just running, that we could query and get the latest data at any time. And we rebuilt the schema completely. So we would read the metadata for the tables, drop all the tables, recreate them as they existed on the hot standby, and then republish everything. And just just tear it all down and rebuild it every time. And as long as that's within the AWS server environment, I don't think you pay for the data exchange. But if it's an external service, that does get expensive if you're pulling in the full data, full truncate and load, or in this case, drop, recreate and load. But yeah, if it's within your budget, that's a good solution as well.
Yeah, and typically what you'll find with kind of schema changes is that there are schema changes that are backwards and forwards compatible, and there are schema changes that are not. And so what you tend to do is you have this kind of agreement between the teams on what things a team can change without telling anybody and what
Mhm.
things they can't, right? So typically things like, hey, if I'm just adding a new field, right, all of the people consuming the event should be aware of that you know a new field being added is not a breaking change. Like, you might need to change if you want to consume that field, but it shouldn't break any of your processes, right? If it does, then from a service and event perspective, there's a lot of people that say like, hey, you're designing your consumption wrong, right?
Right.
Your consumption should be more flexible and more capable to handle those kind of changes. Other changes like changing, say, data types, right? So let's say this field was a description field, and you're putting text in there, and all of a sudden, well, let's take it the other way. It was it was a text field, and now you're putting numbers in it. That's could be a big issue if you kind of change the data type, or removing fields, or changing,
Right.
a name.
Changing the names. Yeah.
Yeah, those are would consider breaking changes as well. And so what you tend to find is that as they change, especially if they might just stop using a column, right? So if they're going to delete it, they won't delete it, but they just won't populate it anymore, or it just may not be used anymore. So,
Well, and
but that won't.
sometimes they'll back populate it as well, which may not come over in an event. So you got to grab the whole thing.
Yeah, back population and new fields is a challenge as well. But yeah, a lot of it is, just having a communication between all the teams, and just kind of expectations
Yeah.
of how things going to work. So
Yeah. And to reiterate, we didn't drop the communication when we were on the change notification team. But at least it meant that our data pull process wasn't going to break outright, and we could just work on downstream things to make sure that they weren't going to break.
yeah. Let's see. So Marcio.
I see a great Marcio's question. I think it's a great one for our topics to vote on. So I'm
I
going to
agree.
copy it in there, Marcio, and we'll vote on if we're going to talk about it. I'm just going to keep the full message there. So sorry if the formatting's weird. And with that, oops, that did not work. With that, are you allowed to copy out of here, Andrew?
I don't think so.
Sometimes I can, sometimes I can't, and tonight I cannot, it looks like.
Yeah, it looks like
I'll type up a bit of that for you, Marcio, if you don't mind me trying to shorten it. And if you have not already clicked the link to check out the topics, please do, and see if there's anything you'd like to talk about as a group. We may or may not have experts on it in the in the meeting tonight, but you could at least hear some experiences. Most people have at least heard some stories or something. We just try and share what we know. Why don't I go ahead? Well, I'm going to type this and then I'll share my screen. So either have a couple minutes of awkward silence, or you all can talk about whatever you want for a minute here.
No, I'll just mention that on the question of microservices, they don't necessarily, and correct me if I'm wrong, but I don't think they should necessarily have to be event driven. So if you have like a nightly loading process that just uses bulk files, drop to SFTP and pull them off and load them up, that could still be a microservice, right? It doesn't necessarily have to be event driven.
That's correct. I mean, you can't, like, if you don't, let's say, for example, you don't have a real-time component to your service, and let's say you just, you want to get a load of all of the orders for that day, right? Then certainly if the service though would need to ensure that that's one of the ways that you can communicate with that service, right? So what you tend to do is say, the service in that case would say, okay, hey, every night at 10 p.m. UTC time, we are going to generate a file and we're going to put it in this location, right? And you have you can go and get it. You can't modify it, you can't delete it or anything else, because other people might want it to, right? So you're basically giving a different way to communicate with that service. And so if that's something that the services want to support, you could certainly do that as well. I think the one thing that you wouldn't do though is typically one thing that the service would not want you to do is to say connect to their database directly and do an export, because now there's dependency on your database technology. So if they switch out and go from Postgres to SQL Server, that's going to break your process, right?
Yeah.
So that's where it would end, where if you're reaching into their service from a data perspective and hitting their data source directly, they tend to say, no, don't do that.
Mhm.
So you want to start the negotiations of how to get their data with, well, if you want me to just go hit your database, I'm happy to do that. And they'll go, no, we don't want that. Then we'll be coupled forever. You go, okay, cool. Then define a schema, tell me what the contract is and send the data, here, or I will come help you do that and get it set up. That's the best way if organizations will let you do that.
Yeah.
All right, I'm sharing the topics we have.